Hello and welcome to this episode of the AI Show. How's it going today? Welcome to this fine, what month are we in? April morning, February. I keep saying February. April 28th. How you doing? First of all, if you can in the chat, tell us where you're coming from, and we'll give a little shout out to you. Why am I off? Do I need to move my camera? No, there we go. There we go. Welcome to this episode of the AI Show. We have some good stuff for you today. Stuff that most people haven't seen. I mean, I don't know. I don't see a lot of people using this stuff out there, but yeah, pretty excited. We're talking about the Realtime API today and how I've used it to bend it to my will. Well, to the will of some demos I was building. But again, tell us where you're coming from. Just put it in the chat. We'll call you out. All right. Let me share my screen here. I got to move this over here. Entire screen. Share system audio. Yes. There you go. There you go. There you go. Okay, now everything's in the right spot. All right, today we are going to be working with the Realtime API. So let me select. No, let's select this color here. So today on the AI Show, we have using the. I should say, let's make it bigger here. And why is this thing still here? You can go away. Using the Azure OpenAI Realtime API. So I tried showing this the other day, but it's broken. I fixed it. Well, I fixed it. John Dakota fixed it. One of our fabulous engineering staff. So the Realtime API is the one that talks to you. And sometimes there's a little bit of misconception of like what's actually happening. And so I thought today we would go through a sample app with some code that I made available just recently, I think last week. So you can use it and laugh at me and say, hey, you should write better code, Seth. You know? So we're going to be doing that today. It's kind of tricky. There's a couple of ways to do it, but I chose a certain way for specific reasons, and I'm hoping y'all can be like, that was dumb, Seth, or wow, that was so good. So we're going to be doing the Azure OpenAI Realtime API today. That is what we're doing. So let's take this down and let's see where people are coming from here. In the chat, hello from Norway. Danny from Norway. Hello, my friend. Welcome. Who else we got over here? A greeting, good vibe, something. It is most appreciated. Hello, Paolo. Thank you. Oh, look at this. Dear Seth, could you please send a message in Spanish for the next Global AI Bootcamp in Guanajuato next May 7th? Queridos amigos, por favor, participen en el siguiente Global AI Bootcamp en Guanajuato el 7 de mayo. Hi. I should have put my effects on. I didn't do that. Okay. So yeah, make sure to go to that Global AI Bootcamp. Hank and friends run that. It's a wonderful program. Cool. All right. So thank you. Again, this episode's a little different because it's going to be more interactive. We're just going to go the full hour with the Realtime API. So please ask your questions and get them open. All this, side of the eye. Get the questions going here, so that we can, so that I can answer your questions. So that's today's show, Realtime API, unplugged, and I'll give you links to stuff. so that you can see how it works. All right, let's get started today on that. I don't know if I have any other music files. I don't. So it's just going to be me and you. All right, so let's talk about the Realtime API first, because it's kind of a tricky thing. And I thought I'd start with some links here. We're going to start, by the way, maybe I should do the actual open. Maybe I should do the actual open so we can make this an evergreen episode. So hold on one second. Let me do that here. Let me close that. Let me do this. And then let me do this. You're not going to want to miss this episode of the AI Show where we talk all about using the Azure OpenAI Realtime on the episode of the AI Show. Make sure you tune in. Hello, welcome to this episode of the AI Show. My name is Seth Juarez, and today we're going to be talking about using the Azure OpenAI Realtime API. And I thought I'd start with a little bit of some explanation of what's going on. So let me bring my screen up here. So let's talk about the OpenAI Realtime API, because it's a little different, because you're actually talking to it directly. There is no like, how shall I say? There's no like, give it something and then something comes back, and it is kind of like that, but it's happening like really, really fast. And so the idea is you have an application that we'll close that there. You have an application where let's just say it's a website where you're literally talking to the website, and audio bits go, and then audio bits from the Realtime API come back. So we'll RT it like this. And so there's a couple of ways to actually make this work. I'll show you. So the first document we want to bring up is the Realtime API guide. I just covered my face, but this is what we're going to right now. So if you turn with me, please, to this particular website, you're going to see that the Realtime API has some good docs, right? And there's two principal ways of dealing with the Realtime API. The first way is over WebRTC, which you see here. And then the second way is over WebSockets. WebRTC is great, but this makes it so that your client-side applications talk directly to the Realtime API. And you might be thinking, that's great. That's great. However, if it's a client-side app, it means that any other processing by nature has to also happen on the client side, which can be a good thing and can be a bad thing, right? Because you may, for example, have other prompts, you may have other code that you want to execute with the Realtime API, but you have to do that all on the client side, and that is not necessarily a good thing. The second one is a WebSockets API, and they say it's great from server to server applications. For your backend, you're building a voice agent over phone, for example. And I did this, right? At the last Ignite, I did a demo where I had the Realtime API call me over WebSockets, which was awesome. It was really cool. But I found that this approach is better because you can actually mediate sockets. Let me show you what I mean. So when I'm working with the Realtime API, notice that this drawing I did here, if you're using WebRTC, so let me bring this. If you're using WebRTC, that means that this connection goes directly here, and this connection goes directly here, right? So there's no middle ground here. For me, when I use the WebSocket approach, I actually have an application here, my own server, and then there's a socket that is created here, so a WebSocket that's created here. And then this has a WebSocket created here, and this application joins those two WebSockets so they can talk to each other. Right? And the reason why this is cool is because on my service, I can do other things, right? Because of this stuff inside of my service. So it's kind of like a mediated thing. So the way the Realtime API works is when you're talking into it, it's sending those literal bits of your voice over, and then the Realtime API takes a chunk of those bits and then responds to them. And so you can either go directly to the Realtime API, which is WebRTC. Or you can use sockets. And they say it's best for server-to-server communication, but I actually find it's best for all communication, because then I can have a service in the middle that intercepts the UI audio bits and intercepts the real-time audio bits, and then makes them kind of work together so that I can spin off other events. Okay. And again, keep those questions coming if you have any questions. So that's what's actually going on in the backend. You can either talk directly to the real-time API using WebSockets, or you can talk directly from your client using WebRTC. I have decided that for my particular needs, even from the client, I'm going to talk to a backend service, and that backend service is going to mediate the audio coming from the client service to from the audio coming from the real-time API. So that's what you see here, the two things, right? You have WebRTC, and then you have the actual WebSockets. So it's pretty cool demo. There's a lot of things in here, but the most important bit is how to connect. So notice that the browser, this is how you set it up, and you're talking directly to the service. And you can see it's all in here. But the problem is, again, you have to do everything on the client side, which was no bueno for me. If we're going to go full Spanish. The second is with WebSockets, where you're connecting directly to the OpenAI API. So let's get into the real-time conversation here, because the sessions are more complicated than just sending text to an OpenAI API endpoint. Instead, you have these audio buffers of you talking going into this conversation, and then you have responses coming out. So instead of me like blatherskiting, let's just run the application, and then we'll get into like what it's doing. Okay, so we're gonna cd web and npm run dev. You're gonna see some errors in there because it assumes easy auth inside of a container. And then the other thing is, remember from my diagram that I have a website. This for us, this I'm like drawing on it. I have a literal pen here. This for us is Next.js. Next.js. And then for us, this here is Fast API in Python. So that's how I'm doing this. I should change the color so it stands out. So we'll delete this here. We'll delete this here, and then we'll delete this here. And what we're going to do is we're going to change the color of this to something else like red. Okay. So for us, this here is Next.js. Oh, man, I'm so bad at this. Next.js. So Next.js, Next.js, and then this here is Fast API and Python. So this is TypeScript, JavaScript, and this is Python. So that's what the application is. So when I start this application, you're going to see that I'm starting the Next.js bit, which is the front end, and then I'm also going to start the back end by hitting this play thing. You can see here that the website is basically standard Next.js. You can see all of that there. And then the front end, the front end is all Next.js. And then the back end is Python. It's Python, all Fast API. So if you look at main, you'll see that it's Fast API. Right? All this is Python and whatever. And you should not use the keys, but I did because I need to fix that. But I have keys in there that are running. I'm not showing them to you. So this is what it's running. And so let me go to the front end here, and let me click on localhost 3000, and then open this up. And then we're going to shift I, and you're going to see a couple of errors. This is just because it's looking for like a route that doesn't exist outside of the container. Yeah, so Easy Auth does that. So let me start this thing up here. This is going to connect to the socket, the backend socket, and you can see over here that it's doing it, right? And then we're gonna talk to it here. So let me go to the desktop here, and then here's a winter. How do I prepare for this? This is just a regular chat thingy that we're all used to. We all know and love. So let me move this over so that this fits a little bit better. And you can see that like this stuff is actually happening, right? It's not, I'm not faking it. You can see that the payload's coming, the context, the action. But there's this score here for calling me. So hey, can you call me to help me out? You tell me in the chat. You can hear me. Can you hear this ringing, everybody? Otherwise, I'll be talking to myself and it's gonna sound really weird. Everyone can hear the ringing? Yeah? No? Yeah? Can you hear the ringing? Can you hear? I'm gonna ask. Can you hear the ringing? Ringing. Still ringing. You can hear it. Yeah. No. Just let it ring. By the way, what's cool is I used like an old school ringing thing. Okay. You can hear it. Okay. Cool. All right. So let me answer the phone call.
Hey, Seth, it's great to talk with you. I hear you're preparing for a snowy camping trip and need some gear advice. You've already got the Skyview two-person tent. How about checking out the Cozy Nights sleeping bag, perfect for staying warm, and the trek-ready hiking boots for sturdy footing in the snow? I can send these suggestions to your screen if you'd like.
That sounds awesome. Can you send those to my screen? I'd love to see them visually.
Absolutely, Seth. The visual suggestions are ready, and you can see them on your screen now. Let me know if you need any more information on them. Great. The visual suggestions are ready for you to view on your screen. Take a look and let me know if you have any questions or need more details.
Peut-être tu peux me dire où est-ce que je peux aller pour faire du camping? Qu'est-ce que tu penses?
Bien sûr, Seth. Pour un camping dans la neige, je te recommanderais les Alpes ou les Pyrénées, qui offrent de...
Peut-être dans l'Amérique, s'il vous plaît.
Bien sûr. Aux États-Unis, le parc national de Yellowstone, les Appalaches ou encore la Sierra Nevada sont des
Domo
endroits...
arigatou gozaimasu.
どういたしまして、Seth。キャンプを楽しんでくださいね。何か質問があれば、いつでもお知らせください。それでは、いってらっしゃい。
All right, stop showing off. So there you go. So this is the actual experience I'm going to show you how to build. And it's pretty impressive. Like I said, this is insane, right? It's like, I won't get into how I did this, but I'll get into like, how is it talking to me and doing stuff, right? So a couple of questions. Oh, good. Everyone can hear it. Everyone. So I'm getting the yeses now. Yes, I can hear it. Yes. But your voice is lost occasionally. Oh, sorry. We'll fix that. Is it connected with Twilio? No, it's not Twilio. This thing is talking directly to the Realtime API. But it's insane because I didn't program it to talk different languages. It just does, right? And my French is not so good, right? My Spanish you heard before was okay, but even me talking to it in bad French, it responds to me. It responded to me in Japanese. You can see that there. It's quite impressive. And the thing about this is that it's pretty cool. Once you understand what's happening, you can build really cool applications for this. So this is the application we're building. And just to give you a sense, like you can see, like it's actually happening here. Here, let me start it again so you can see the actual thing happening.
Salut Seth, je suis ravie de t'aider à préparer ton voyage en camping dans la neige.
Hey, let's speak in English. Can you hear me? Did I break you? Yeah, so it looks like I broke something. So I'm gonna hang up on it. But notice that I think it's because I didn't clear its buffer or anything. But notice that it's pretty cool. So let's talk about how this actually works, and how we built it. All right, so let's go back to this thing. What was the one issue here? Oh, the socket's closed. So I need to actually close it. I broke something. I broke it. Okay. So let's talk about how the conversations actually work. So what happens is I'm actually audio buffering stuff from the client, sending it to Fast API, that then sends it to the Realtime API. And so this is how it works. And instead of like it being text, it's actually audio for a user and assistant message. There's some text events that happen as well that you can get a hold of. By the way, this is the WebRTC channel. When you're looking at it from the point of view of the sockets, there's some other events that go on. So let me go to the Realtime API. And you can see that there's a couple of things you need to do. Like you need to create a session. Once you create a session, then you need to send events back and forth to it. Once you send, there's events that come that you can send from the client, and then there's events that come from the actual server. And you need to handle both of those. And so you have two web sockets, one that's getting audio from the client, and then the one that's sending and getting audio from the server. So we're going to talk about the server side first, because it can get confusing if we don't look at it close. So we're going to look at the server side here first. So we'll look at this interaction first, and then I'll show you how this interaction works. So we're gonna focus primarily on the server here. So let's start first with this notion of there's a bunch of server events that we get from the actual API. So for example, things like, hey, a session was created, a session was updated, or a session item was created, right? You have some audio, some transcription, so you get the text. So notice that it actually had the text of me talking. So there, it does transcription. And then we have some VAD, voice activity detection, of like, hey, has speech started, has speech stopped? And as you're looking at the app, you can see all of this stuff happening. So when we talked before, you can see that there was a session created, a session was updated, a response was created, output item was added. You can see the audio done, transcript done. You see that? And so it just keeps doing that. And this here, you're seeing there's some other things happening. That's because the client side is asking for more LLM support from a different model for something else that maybe I'll cover in a different session. And so you can see this is all just happening all the time. There's this thing called input audio buffer speech started, which indicates that I'm talking. And that's why it's kind of interruptible, because the server VAD, or voice activity detection, issues an event from the server side that said, hey, some speech has started. And so I can actually stop the thing from talking. And so that's what I'm doing when I'm interrupting it. It's alerting me that it's hearing talking. And then what I do is I clear the buffers so it stops pushing audio out. And so that's the event. The first thing that's important to note is that the session is the thing that happens first. You create a session, and then so this has the if you're doing it with REST, I'm doing it with the SDK, but you have to create a session, and then you can actually update the session. The session object is nice because you can actually do a bunch of things. So for example, whisper is the transcription. You can give it a different voice. So Alloy is a different voice than the one that you heard. I put one in there. And so you can actually create the session, and then you can update the session with these values. And so that's precisely what I do. So when we go to the actual main entry point of Fast API, you can see that all the way down here, there is this voice thing. And what it does is I'm getting a web socket from the website, and the website's WebSocket is going to send me audio. But the first thing it does is it gives me all of the chat items from before, so that the voice activity, so that the Realtime BI has context of what we've been talking about. That's why when it started up, it's like, hey, I hear you want to go winter camping. How does it know? Well, I have to send it into its system message, because the voice API also has a system message. I have to send into a system message all of the previous chat stuff. And then I get some user information, like, for example, what's the username? That's how it knows to talk to Seth, because it's That's what I sent in. And then I send in any past purchases and then context of like what it's talked about before, as well as all the products that are available in our catalog. And I just stuff it in the system message. Pretty sneaky, right? So at this point, like I'm unveiling all the it's like it's going to start to feel like it's not magic. It's going to start to feel like these things are like puppets that we have to like pull the strings of, right? And that's the actual magic of it. And by the way, feel free to ask questions as we go. That way I can fill you in what's going on. So this is how I set up my system message. And then what I do is I create a real-time client of my making. I'll show you that. I pass in two things. The WebSocket to the website and the real-time connection to the real-time API. Those two sockets that I told you I'm marrying together so that they can talk to each other, right? That's what that real-time client does. And the first thing we do in that real-time client is we update the session. So if we go to this thing, you can see I'm updating the session. And so I'll give you an example. If I change this to Alloy, right? I think Alloy will work. This will see that there's a change that happened in here. Hopefully it'll restart, or maybe I need to full restart it. Okay, reloading. I hit stop. No, I do not want to do that. Holy cow. Uh-oh. Oh no. I hate it when this happens. Because then I have to go into my task manager. Dang it. And then I have to go find my Pythons. Where's my Pythons at? ALMNOP. Python end task done. Now I can go like this. I had to end my Pythons. Okay, so there's this thing. And so now when I turn it on, you'll hear it talking differently, right? Because it's a different message. So I really want people to understand that this is actually happening. Because I've seen a lot of AI demos, and a lot of them I can tell were like a video that were jump cutted because I know something about video. So now when I talk to it, I won't send it any of this context.
Hello, Seth. How can I assist you today with your outdoor gear needs?
Hey, thanks for your help. I just wanted to hear you sound different.
I appreciate that, Seth. How can I help you with your outdoor gear today?
I'm going to go.
All right, Seth. Feel free to reach out if you need any help. Have a great day.
Okay, so notice that what I did is in the update message, I just changed the voice. And you can change anything. Like, for example, notice here I'm using server VAD, which is session turn detection. And you can see that anytime it had new speech from me, speech started, speech stopped, speech committed, conversation item created. And then it created a response. And then it created an output item. And then it sent some audio. You see that? And so it's very specific, like exactly what it does. Okay. So this is the update that I do from the thing. I'll keep the other. I like the other voice. And then once it's done, this is the bit that may be confusing, is that there's two async await tasks that we create that are while loops that for over everything forever until the sockets are closed. And this was the part that was a little tricky for me, right? But once I understood it, it made perfect sense, right? The idea is that instead of polling, we will get pushed audio that will get handled, and then it'll stop and await something else. So, for example, here, when I go to receive client, go to definition, you're going to see there's a bunch of, this is the client from the website. You're going to see that there's like a while not disconnected, get stuff. And then once it gets stuff, if it's an audio message that I'm getting from the client, I send it to the real time. If I'm getting a user message, like somebody typed something, I send it to the Realtime. If I get an interrupt, that means stop what you're doing. It means create a new event on the service of the Realtime API. I'm interrupting you. And then this is if there's function calling, because you can do function calling with this, but I didn't implement that here. If there's something else that's going on, then I send back to the console like, hey, I don't know what the heck's going on. So that's the client. And notice that the thing about this is that it's just a while true, or I guess while socket, do this forever. And notice that because there's awaits on all of these things, it will like go to that thing, get stuff, stop, yield to something else, come back, go to the next thing, do the await, yield, go to something else. And so that's what's happening here. The real-time one is much more complex because there's more events that need to be handled, like all of these server events I get. And what I did is, let me go to the Realtime. For each one of the events, notice while is not none, for each event that I get from the Realtime, I handle each one of them in its own function. Do you see that? And so this is exactly the same as the client, except for when I get a server thing, then I got to know what to do. So for example, most of them have passes in them because I don't do anything. But for some of them, they don't. Like, for example, when a transcript is completed, that means that there is a user message that I sent back. That's why when I say something, it shows up in the chat. And then when I go down here, you're going to see when there is a speech started, that's the server voice activity detector saying, hey, Seth is talking. And so I send an interrupt to the client to say, stop the buffer, stop playing whatever you're playing so that you can talk. And then here is this one. If there is a response done, then I send the message to the console. And that's why you see in the console over here, you see all these outputs, right? Because I'm just sending them for debug purposes. So I can see that it's actually working. And then the audio one, I got to find the audio one. And then if there's any items that are left over, I send them. There's a queue. That way I don't overwhelm the real-time API. I kind of buffer stuff. There's the audio transcript. When the audio transcript is done, I send something from the assistant. And then I got to find the audio. No, where's the audio? Not audio. There's so many events that happen. Not that one. Gosh, where are you? I bet I can just do control. Wow, so many audio things. Here, there it is. So when I get an audio delta, I send the audio back to the client and I say it's of type audio. Right? So the client knows, oh, I'm going to handle this audio message. So this is the actual service. And that's it. The main point of understanding is that when I create the session, I put these two sockets together into a client, which is the real-time client. And these things now are joined together. And so I async await for the loop on the real-time. I async await on the client. And these things like get stuff on and yield to each other. And sometimes when something happens on the client, I send something to something happens on the real-time API, I send information to the client. Sometimes when stuff happens on the client, I send stuff to the real-time API. But the gist of it is that primarily when it comes to audio, if the client gets audio, I send it to the real-time. If the real-time gets audio, I send it to the client. And that's how this beautiful thing is set up, because those two sockets are put together. All right, so let's see. How do I find pricing? Here's a question. How do I find pricing for it? Let's look together. Azure OpenAI real-time API pricing. Here it is. Azure OpenAI service offers a variety of pricing options to cater different needs and usage patterns. The pricing structure based on the type of model, deployment, blah, blah, blah. Standard pricing, global deployment input $2.50 per million tokens. Cached input $1.25 per million tokens. Output 10 per 1 million tokens. PTUs are more expensive because it's provisioned, right? The cool thing about the Realtime API is that multilingual speech just works. You can do chat completion APIs. There's just a lot of cool stuff in there. But this is the actual price. And let's double check to make sure that the model is not GPT-4.5, O3 Mini, real-time. Yeah, there we go. Real-time API, text input 5, cached output audio 40 to 50 per million tokens. And these data zones are a little bit different. And I don't know how much a million tokens is. I should probably, like this conversation we just did, let's see if I can't figure it out. AI.azure.com. This is the backend here. Let me go to my Contoso concierge here. And I think there is a dashboard now, that management center. Oh, I don't think it's in this project. I'll find it. That's a good question, though. But the pricing is here. You can see all this here. And so the question is, well, how much did you spend just in the last little bit? This is per million tokens. I don't know how many tokens I just spent. I should have had them, like, I should output how many tokens. I think in the rate limits updated, you get that information on how much was used. So let's go over here. A minute at the beginning of a response indicate the updated rate limits. When a response created, some tokens will be reserved for the output tokens. The rate limits show reservation, which is then adjusted accordingly. Once. Okay, so this is how much it's reserved for the next thing, and so you get a sense of how many tokens when you play with it. But I'll get a better answer later. This is for voice and video. No, this is just for the voice stuff. There's no video. This API, because there was an earlier API which you could see stuff, This one does not. This is only voice. However, having said that, you can use other models. Like for example, when I did this bit of like talking to it when I sent the picture in here, that was using 4Omni. Regular, and then because I have a description use it for Omni to create a description of the picture. The real-time API had understanding of the picture because it had a description from a different model. So you can compose models to do some of this goodness that I'm talking about here. Okay, so that is the pricing. Okay, so we talked about the server side, and by the way, if you're wondering, like, well, hey, I want to look at this. You can look at my garbage code. Not garbage. It's good code. It works. Here, the Contoso voice agent examples on GitHub. So you can totally just look at it as well. Yes. In fact, it's right here. You can see it right here. And so the API is there. My envs are not in there. And then you can see, like, I actually deploy this thing quite regularly, because I do this demo for the AI tour, which, by the way, for those who are in DC, Washington, DC, I will be at the AI tour next week on May 6th. I will be in DC to present this stuff, so come say hi if you're available. All right, so that's what. So you'll see, like, this demo I've been doing for a while. It's almost been 6 months, and you can see like how I fixed everything, etc. So that's when my basic real time all the way down to like today stuff I got, right? So there's a couple of things. I use an unreleased real-time API, and I got rid of that because it's not useful to use a wheel file in my code, and so that's what you'll see. And then I add certain people to the demo as well because I need their picture, right? Okay, So we talked about the server side. Feel free if you have any questions about the server side, let me know. But that's the gist of it. The gist of it is I created a fast API endpoint that took a socket from the client and then merged it together in a single object called the real-time client with the real-time API's socket. And that's what actually, and then what I do is there's a while loop for the client and a while loop for the service, and then I async await while they're alive so that they kind of yield to each other when things happen. And that's what is going on there. Tricky, I know, but it works. Okay, now let's get into the website because it's very responsive. Like, it's uncannily responsive. And the reason why is because, and this is going to get into some in the weeds of like audio on a browser, because it's important to recognize that when the reason why it's so buttery smooth is because I'm using something that's similar to a web worker. Let's talk about that now. So we did this thing. So let's move this up and let's talk about the oh, my thing turned off. Let's turn back on. Here we go. Okay. So now we're going to talk about the client side, because handling this stuff in JavaScript is not it's not for the faint of heart. I'm pushing the wrong. Here we go. There you go. It's not for the faint of heart. So let's talk about it now. So what we want to do is we want to make it so that the website, so let's pretend this is the website. We want to make it so that the website does not use the UI thread, the UI thread to process audio, because otherwise your website is going to be super laggy. So we need to find a way to have like an input and an output socket, pun intended. So this would be like your microphone. And then this would be like the service audio. So this would be the out and this would be the in. And remember, we're kind of putting the cloud here, but this is our fast API thing. Because this was simpler, right? Because we had two, we had those two, the real-time API socket and the client socket talking to each other. So we need to have a way to send to, and so this is for the audio. And then we need to have a socket as well, a web socket that we send over, that we get from this service that then can talk to us back. So those are the two major concerns. And this, wow, I can't even read this. So this would be the audio in. So those are the two things we have to figure out how to do from the client side. So let's start with the WebSocket first. Maybe we should start with the audio worklets. Okay, so let's start with the audio worklets, because this, again, like I said, it can be tricky. So the first thing is we need to have some way. We'll do the socket. We'll do the audio stuff first. We need to have some way to attach an in and out buffer coming from the website that is not snapped to the UI thread. Like, obviously this is all React. I say obviously, maybe it's not obvious, but Next.js has React in it. So that is where we start to use something like a audio worklet MDN. Here. So this is something called an audio worklet. And the cool thing about the audio worklet is that it allows you to process audio outside of the UI thread and inside of the audio pipeline process. So you actually have to create this processor. And we're going to make two of them, one for getting input and one for doing output that captures them. So think of like the audio as a pipeline, and you are injecting this worklet processor into the pipeline. So let's go to some code here so that you can see it in action. The first thing that's different is that I think web workers are the same. Web workers have like an outside class or file. I'm trying to remember what web worker separate file. They do. I haven't done a work. Yeah, we don't want it without a separate file. But you can see that a web worker, you basically, with a dedicated worker, you actually create an entirely separate JavaScript file because it's a separate process and needs to grab that and put it into, its runtime, which is cool. So just think of like a worklet as a baby worker, but worklets are only for audio. Okay. So for us, notice that in the public, we have two worklets. We have one for playing audio, right? So port on message, handle message is .bind. You can see that we're pushing audio into the buffer. And then we're getting the channel and we're outputting the actual audio to the buffer. You see that? And we can only send a certain amount, right? So if the channel length is if it's greater, then we splice it and we send it. Otherwise, we just empty the buffer. And so notice that this is a completely separate audio worklet process. And so this plays the audio that I get from the service in a separate thread. I'll show you how we actually set these up though. But notice that this is like a module or a thing that's running inside of the audio pipeline. The next one is for processing the mic or the audio. You can see here that this is a PCN processor because I need to convert the audio that comes from the mic. And what we're doing is anytime we process this stuff, right, we're getting the inputs, we convert it to int16 buffers, and then we post the message to this port, right? Because, and again, notice that notice there's two things happening. They're both similar, but they're the other opposite ends. This is sending bits to an audio channel so we can hear. This is grabbing bits from an input channel, an input buffer, and sending it to whoever's listening to this worklet. Okay. So that's what this is. So these are two separate processes, and this allows us to move this work to outside of the UI thread inside of the. Have I lost anybody? I want to make sure that because it feels complicated. It is, but once you get it in your head that you're actually using processing bits of audio going out and coming in on separate threads inside of the audio pipeline, that's what makes it so smooth. Okay. So how do we put these things together? Well, that's where we get into the actual audio bit. And the audio bit has a player class and a recorder class that uses these worklets to do work. So for example, for the player one, right, anytime it gets a buffer, it posts a message to that worklet. It handles the message and puts that into the buffer, and then the processor is called. You see, so this is how we talk from the player class inside of the application to the worklet. We are passing. So we initialize this thing, right? We get the audio context. We initialize the worklet. But anytime I call player.play and send it bits that I'm getting from the Realtime API, it posts the message, the buffer, to this thing, and then this thing takes care of pushing it to the audio output so we can hear it. Good so far? So the question, so it's not processing a WAV file. Here's a question. So it's not processing a WAV file at all. It's getting the literal audio buffer from the service to the client. Right? And we actually send the buffer. So this is for the playback. Whenever I get a in the player, whenever I get audio, I call play. So for example, go to references. Let's see if we have any. Where are the references to this? Go to find all references. No, there's more than this. Come on. I'll show you. I'll show you where it happens. So this is the easy one, right? Because we are just going to get audio that we're going to play. So we'll just get audio from the WebSocket and we'll play it. The recorder buffer is a little more complicated because we need to actually get like a media stream, right? So the first thing we do is we get the worklet, we get the media stream, we create the new audio worklet node, and this node, whenever it gets, what we're doing is we're passing a on message port. Whenever it gets the actual buffer, it actually pushes stuff into the buffer, and then it connects. So you're probably looking at this like saying, what is this? So let me go to the audio worklet processor and split it to the right so you can see it. Notice that we post a buffer from the worklet because it's been hooked into the pipeline for the content. When it gets this message on, like I am getting this message, it does a conversion and says there's data available so that our service can push the audio back. So this gets the audio, it posts the message, we get it here. And then we do stuff available. We do stuff with it. And the thing we do with it is we say there is data available, and there in the constructor, it's getting a function to say this is what we do when the data is available. So there you go. And this is a stop, right? Because we're getting media tracks. So what we do is we connect the media source to this worklet node, and then we connect it to this destination. So this is the opposite of the other thing. It feels a little bit more complicated, only because we have to handle anytime we get audio buffer bits from the actual this thing. And so notice that when it gets an input, it converts it float 32 to int16, posts a message, we get it here, we fire the function that says we have a data available. That function is passed into this class in the constructor. So somebody is using this recorder to be notified when we get audio bits from the actual microphone so that we can send it back. Okay, so there is that. How do we marry all of this together? Well, to do that, we use a hook, a React hook. So that, for example, when I'm using this in the actual website, let me go back to the app. I think it's in the page. No, it's in the voice. So go to definition and the voice thing. Notice that for me to use the web thing, I just say const use real time, and there's a start, stop, send, call, and set call state. Right, and then I send in this action client that does stuff. So this is the use real time. If we go to this definition, you'll see that this gets a user, who the current user is. It gets this action client, which basically is just a way to send events to the website. And to start the real time, we create a voice client. Hold on, where did I put this? Oh yeah, sorry. No, this is exactly this is the voice client, right? I think I showed you this. No, I didn't show you that yet. Okay, sorry, I got you. So this starts it, and then what I do is I put the two together, just like I did on the server side. The voice client, the voice client gets the socket that's talking to the thing, the player and the recorder, and then I set a handle server message. And so when I start it, I create a new WebSocket to the URL, which is the URL of the fast API thing. I initialize the player. There's the recorder. I say new recorder, and notice that I have to pass in a function. That function says anytime I get code, I'm going to send it to the socket as audio in base64, and that's it. And then I do I send the recorder stream, and I start the response listener, and the response listener is basically an async server event back and forth. Okay, there you go. Yeah. By the way, I know I went through it really fast, and I know that it looks complicated because it kind of is. My sense is that I think I want to make an NPM package that kind of handles all of this for you, so it's a little bit easier to talk to the service. But effectively, what is happening is we'll go right here. We have the audio worklets. These two things are audio worklets, right? These two things are audio worklets that process things separately and post messages back and forth to this thing. That way we can handle the audio buffers in and out on a separate thread. We join these things in the voice client, and inside of the voice client, we create instances, or we start up these audio worklets, both of them, and then when the recorder gets stuff, we post it. So we'll say this is the recorder. We post it to the Realtime API, or not directly. We post it to our fast API backend, and then it handles the rest. When audio comes in, we push it into our player. And those processes are all happening outside of the context. Whew. Yes. Does the buffer size depend on the quality of the audio we select? There's a standard buffer size. Standard buffer size. That's why when you're looking at this stuff, you can see that it's using an N16 array. And then you can see that in the play, when we're sending stuff into the you can see there's a channel length, but yeah, so there's a buffer size. I think in reality for me, when I do the playback, when I do the recording, no, that's yeah, there's a channel length. This is outputs though. This is playback. We don't want playback. We want this thing. Yeah. So there's a size. So this math, I'll need to look at this math. But we have to do some conversion. But I don't have time to get into that. So the question is it placing it into a queue, Courtney? No. So what's happening is it fills the buffer up and just sends it. So you see that, like, as soon as it gets the audio, it just literally just starts sending it to the API. So this post message, when I go to everything, like, where is this doing this? Well, it's posting the message back here but we are setting an event a function to handle this, right? So notice that there is a specific size of the buffer, right? So there's a target size of buffer, 4,800. I'm concatenating the buffer and then saying there's data available. And then the actual voice client, you can see here, the voice client, whenever it gets the buffer, it sends it directly to that. Okay. Alrighty. Whew. We are out of time. Let me stop sharing my screen. Maybe we'll visit this again a little bit slower because it's a tricky little beast. But notice that I've shown you some pretty low level stuff, so you can get a sense that like this is actually using audio to talk. It's not like it's not faking anything or doing stuff in a way that's like not real. All right, friends. On the next episode of the AI Show, make sure you tune in next week, 8:30 a.m. Pacific. We'll be talking about semantic kernels agent framework with Sean Henry. We'll have a 9 a.m. Pacific time Azure AI Foundry extension for Visual Studio Code April Spate. She is amazing. I am going to be in DC, so I might we're going to pre-record parts of it, but I might pop in to just shepherd those things together from my hotel room in the District of Columbia. So thank you again for coming. I appreciate everything. And if you have any questions or comments, please let me know. We would love to do more shows like this. Thank you so much for watching. And hopefully we'll see you next time on this, the AI Show Live. Take care.